Li-ion batteries are everywhere. They power our phones, laptops, and even electric cars. These batteries are small but mighty. They store energy and release it when needed. This makes them perfect for portable devices. Imagine a battery as a small container. Inside this container, a special process takes place. This process allows us to store and use energy whenever we want. Li-ion batteries are rechargeable. These batteries use lithium ions to move energy. These ions flow between the positive and negative parts of the battery. This flow of ions is what creates the electrical current. Li-ion batteries are changing how we use energy. They are essential for our modern world. From smartphones to electric cars, they power our lives. A Li-ion battery has four main parts: the anode, cathode, electrolyte, and separator. Each part plays a crucial role in the battery's operation. The anode is the negative side of the battery. It's like the starting line for the lithium ions. The cathode is the positive side. This is where the ions go when the battery is discharging. The electrolyte acts like a bridge between the anode and cathode. It allows the lithium ions to move freely between the two sides. This movement is what creates the electrical current. The separator is a thin, porous material. It sits between the anode and cathode. Its job is to prevent the two sides from touching. If they touch, it can cause a short circuit and damage the battery. The magic of a Li-ion battery happens when these four components work together. During discharge, lithium ions move from the anode to the cathode. This movement creates an electrical current that powers our devices. Think of it like a game of tag. The lithium ions are like runners. They start at the anode and race towards the cathode. As they run, they create energy. During charging, the process is reversed. Lithium ions flow from the cathode back to the anode. It's like the runners are returning to the starting line, ready for another race. This back and forth movement of ions is what allows Li-ion batteries to be recharged. This is what makes them so useful for portable electronic devices. The charging and discharging processes are like two sides of the same coin. During charging, we use external electricity to force lithium ions back to the anode. It's like pushing the runners back to their starting positions. Discharging is when the battery releases stored energy. Lithium ions flow from the anode to the cathode, creating an electrical current. Imagine the runners racing towards the finish line, generating energy in the process. The amount of energy a battery can store depends on its capacity. This capacity is measured in milliampere hours, or mAh. The higher the mAh, the longer the battery can power a device. Section 5. Powering our lives. Applications of Li-ion batteries. Li-ion batteries are all around us. They power our smartphones, laptops, and tablets. They are essential for our connected world, but their uses extend far beyond portable electronics. Li-ion batteries are also used in electric vehicles, or EVs. They provide the energy that powers these vehicles, reducing our reliance on fossil fuels. These batteries are also used in renewable energy storage systems. They can store energy generated by solar panels and wind turbines. This stored energy can be used when the sun isn't shining or the wind isn't blowing. From powering our devices to enabling the transition to cleaner energy, Li-ion batteries are transforming our world. Section 6. The advantages of Li-ion, why they're everywhere. Li-ion batteries have several advantages over other battery technologies. This is why they are so widely used. Firstly, they have a high energy density. This means they can store a lot of energy for their size. This makes them ideal for portable devices where space is limited. Secondly, Li-ion batteries have a low self-discharge rate. This means they lose their charge slowly when not in use. This is why your smartphone still has some battery life even after being left unused for a few days. Thirdly, Li-ion batteries have a long lifespan. They can be recharged hundreds of times before their performance starts to degrade. This makes them a durable and cost-effective energy storage solution. Section 7. The challenges of Li-ion, overcoming the limitations. Despite their many advantages, Li-ion batteries also have some limitations. One challenge is their cost. Li-ion batteries are relatively expensive to manufacture compared to other battery technologies. Another limitation is their sensitivity to temperature. Extreme temperatures can affect their performance and lifespan. This is why it's important to avoid exposing your devices to very hot or cold conditions. Safety is also a concern. Li-ion batteries contain flammable electrolytes. If they are damaged or improperly handled, they can overheat and catch fire. However, ongoing research and development are focused on addressing these limitations and improving the safety and performance of Li-ion batteries. Section 8. The future of energy storage beyond Li-ion. While Li-ion batteries are currently the dominant energy storage technology, researchers are constantly exploring new and improved battery chemistries. These next-generation batteries aim to address the limitations of Li-ion and meet the growing demand for energy storage. Solid-state batteries are one promising alternative. They use a solid electrolyte instead of a liquid one. This makes them safer and potentially more energy-dense than Li-ion batteries. Another area of research is lithium-sulfur batteries. These batteries use sulfur as the cathode material. Sulfur is abundant and inexpensive, making these batteries potentially cheaper than Li-ion. The development of these new battery technologies is crucial for meeting the growing demand for energy storage in electric vehicles, renewable energy systems, and other applications. Section 9 Conclusion. Li-ion's lasting impact. Li-ion batteries have revolutionized the way we live, work, and play. They power our portable devices, enable the transition to electric vehicles, and support the growth of renewable energy. While challenges remain, ongoing research and development promise to further improve their performance, safety, and affordability. As we move towards a more electrified future, Li-ion batteries will continue to play a crucial role in powering our world.